Welcome to ONT Lab number 1. ONT, that's Cisco's Optimizing Converged Cisco Networks. And in ONT Lab number 1, we're going to focus on placing a couple of voice over IP phone calls in a Cisco IP telephony environment. Specifically, we're going to use a software-based phone called the Cisco IP Communicator to place these phone calls. We're going to, at the beginning of this lab, examine some of the properties of a Cisco IP communicator, and then we're going to place a phone call over to a hardware IP phone, a Cisco 7940 IP phone. And that very first phone call is going to be placed using the G.711 codec. Codec, that stands for coder decoder. It's the way we represent audio inside of our IP packets. And G.711, something important to know about this, it does not do compression. It does not compress the audio down. It simply does pulse code modulation. As a result, payload only, the G.711 codec requires 64,000 bits per second of bandwidth. Again, payload only, we're not including overhead in that number. Once this call is in progress, we're going to view the call statistics. We're going to make sure that we are indeed using the G.711 codec. And then we're going to use a packet capture utility. It's called Ethereal, to capture some of these voice packets to see what the size of these voice packets are. Then we're going to change up our configuration such that we begin using the G.729 codec as opposed to G.711. And G729, that does do compression. That is going to require 8 kilobits per second of bandwidth, payload only again, for our audio. We're going to view call statistics for that G.729 call and compare those statistics to the statistics of the G.711 call. Let's take a look at our topology that we're going to be working with. We have a fairly simple topology. We have 2 IP phones. One IP phone is running on the PC you see on screen. That PC is running the Cisco IP Communicator software. That's acting as an IP phone. And we can plug a USB headset, as an example, into our PC to use that phone. The other phone in this topology is a hardware phone. It's a Cisco 7940 IP phone at the bottom part of the topology. And then what I call the brain of Cisco's IP telephony network is the Cisco Unified Call Manager server at IP address 192.168.0.25. Let's go out now and take a look at that Cisco IP communicator. If we go out and open up our Cisco IP Communicator application, we see that it looks almost identical to a hardware IP phone. In fact, it really reminds me of the Cisco 7970G phone. We can manipulate some of the properties of this phone by right-clicking inside of the display and selecting Preferences. In the Preferences window, something I'd like to point out to you under the Network tab. Under the Network tab, we can hard-code the IP address of a TFTP server, a Trivial File Transfer Protocol server. Notice the IP address. It's 192.168.0.25. That's the same IP address that we saw in our topology for the Cisco Unified Call Manager server. That's an important point. We can have a TFTP server co-resident with our Unified Call Manager server. And this TFTP server is critical because it's from the TFTP server that our IP phones download their configuration file. This configuration file contains such information as what Cisco call managers are available that this phone could register with. It also tells what the soft keys, as another example, should be. The soft keys, these are represented by the buttons on the bottom part of the display. These buttons right now, it looks like we have redial, new call, call forward all. These are soft keys, and the reason we say they are soft keys, during different call states, they take on different behaviors. Right now we're in the on-hook state, so we have the behavior of redial, new call, and call forward all. If we were in the off-hook state, in fact, let me go off-hook, you can see that these soft keys change once I go into the off-hook state. Let's do this. Let's go ahead and place a voice over IP phone call. We'll click on New Call, and let's call extension number 2000. You could probably hear that ringing in the background. We're calling extension 2000. That's our 7940 phone. We go off hook on extension 2000, and Let's check out some call statistics. We can do that by double-clicking this question mark button on the phone. We could do the same thing by quickly pressing the question mark button twice on a hardware phone. This is going to give us call statistics information. Here's what I'd like to point out. We can see the receiver's codec and the sender's codec, and they're the same. They're G.711, and notice the U, that's representing G.711 mu law. It's the Greek letter mu, mu. However, the display does not support the letters in the Greek alphabet, so it's represented as a U. The other flavor of G.711 that you might see is G.711A for alpha law, as opposed to mu law. However, in the United States, it's common practice to use G.711 mu or U law. We've now verified that we are indeed using G.711, but did you know that we could also go to the phone via a web browser? Let me show you this. Let's go to the other phone. Let's go to the 7940 phone that we were talking about. That 7940 phone is accessible at IP address 10.8.8.2. And we can see information about that physical phone. We see its MAC address, we can see its serial number, lots of great information about the specific piece of hardware. But check this out. Because we have a phone call in progress, we can click on stream 1, which represents that voice stream. And we can get specific statistics information about the voice call in progress right now. If we scroll down a bit, here's what I was looking for. We can see which codec is being used. And again, we're having this confirmed for us that we are using G.711 in this instance. While this phone call is in progress, let's do one additional thing. Let's capture some packets. There is a free packet capture utility available on the internet, and it's called Ethereal. Available at ethereal.com. You can go out and download this Ethereal Network Analyzer, and I'd like to use it right now to capture some of these streaming audio packets. And as I do this, please be aware that I'm doing this in a lab environment, not on a production network. Before you attempt something like this, please seek competent legal counsel, because the capturing of packets may be considered wiretapping. And the laws may vary state by state concerning how many parties in the call know that the packets are being captured. So please be cautious and consult an attorney as well as your company's own policy before attempting this. But in this example, I am the party at both ends of the conversation, so let's proceed. I'm going to click the New Capture button, and we're going to say that we want to start capturing these packets, and we'll let it run for just a few seconds. And while it's running, I'd like you to notice that we're starting to collect primarily UDP traffic. Why is that? Well, UDP encapsulates RTP, the real-time transport protocol, and it's RTP that's going to be carrying our voice packets. Let's go ahead and click Stop now. I think we've captured a sufficient number of voice packets. By the way, in the Cisco environment, UDP port numbers that carry voice packets, they're going to range in the UDP port range from 16,384 through 32,767. And we do see in the output UDP port numbers in that range on screen. It looks like we have a couple of numbers. We have one representing each direction of this RTP flow. Here's what I would like to do. I would like for this to show up as the RTP protocol rather than the UDP protocol, because we have the knowledge that this is what Cisco is using for RTP. This is what we can do using Ethereal. I can right-click on one of these packets and say that I want to decode this packet as, and we can select what protocol we want to decode this packet as. I'm going to select RTP. We scroll down a bit, and let's select RTP. So now all of these packets show up as RTP. And RTP has a payload type field. It says what are the contents, what is the formatting of this RTP packet. And you notice on screen that it says the payload type is G.711, and PCM, that's pulse code modulation, and the U, that's representing mu law, That is also confirming what we just saw from our web page and from the display on the Cisco IP communicator. Something I'd like to point out, though, about this voice packet that we're analyzing, if we look at the frame size, look at the size, it's 214 bytes in size. Let's remember that number. We're going to compare that number to the frame size of a voice frame using the G.729 codec in just a few moments. One other thing I would like to point out using the Ethereal Network Analyzer, if we open up layer 3, if we open up the Internet Protocol header, we can look at the quality of service marking for this packet. There's something called the differentiated services field. This is made up of the 6 leftmost bits in the TOS byte, the type of service byte in an IP version 4 header. And we see that this differentiated services field has marked this packet as having a priority of expedited forwarding. That is very high priority. That is the priority that we want to use to mark our voice packets. Now that we have analyzed a G.711 phone call, let's change our configuration such that we're going to be using G.729. Those of you that have worked with the Cisco Call Manager, you may recall how to do this. We can go out to the Call Manager administration screen, and even though this is not an ONT topic, I thought it might be fun for you to see this. We can go into the region configuration for these phones, and we can change the default codec from G711 to G729. We'll click on Update, that we want to update this on all of the devices associated with this device pool, as it's called, and then we will restart those devices to have this change take effect. We'll go ahead and have those devices reinitialize, and after those devices have an opportunity to reinitialize, we're going to place another phone call, this time using the G.729 codec. Let's go back out to our IP communicator phone and see if it has reinitialized. It looks to be in good shape. Let's place another phone call. Let's go off hook again. We'll click on New Call, and let's dial extension 2000. Again, you can hear the phone ringing in the background. Let's go off hook on extension 2000. And let's verify that we are using the G.729 codec this time. How can we do that? One way we can do that is by double-clicking on this question mark button on this IP communicator. This tells us that we are using, look at this, the G.729 codec. This is the compressed codec. Let's now go back out to our Ethereal packet capture utility, capture packets that are part of this voice phone call, and let's compare the size to the G.711 frames. If we open up Ethereal once again, let's say that we want to begin a new capture, and I will indicate that I want to do that new capture without saving my existing capture. We will begin the new capture, and we will collect additional UDP packets, which we know are carrying the voice packets. We see the UDP packet counters begin to count up. I think that's enough. Let's go ahead and stop this packet capture, and let's select one of these UDP ports. Let's right-click it and say we want to decode this as an RTP packet. We know that Cisco is using UDP ports 16384 through 32767 to represent RTP. Let's go ahead and change those to the RTP format. Again, we see the differentiated services field is using expedited forwarding as a very high priority marking. We're treating the voice packets better than other types of packets on a QoS enabled network. But here's the main thing I want to point out. Notice the frame size. Look at this, 74 bytes using G.729. Do you recall what it was when we were using G.711? That's right, it was 214 bytes. You can see that there is a dramatic bandwidth difference between G711 and G729. Is there a quality difference? Technically, yes. There is some quality difference. However, to be honest, during a regular phone call when I'm talking with someone, I probably could not tell the difference. They're that close. But perhaps a time where you will be able to tell the difference in voice quality is when you are listening to music on hold. because G.729, its codec was optimized for Latin-based speech patterns. It was not optimized for music. With music, you can definitely detect a degradation in the audio quality. However, with regular speech, it would be very difficult to detect. So let's review where we have been in this lab. In this lab, we placed a couple of voice over IP phone calls and did some comparisons. We said that we wanted to use the Cisco IP Communicator application, a software-based phone, to place these phone calls. So we began by taking a look at that software application, the Cisco IP Communicator. Then we placed our first phone call. That first phone call used the G.711 codec. It did not do compression. It did not compress our audio packets. We viewed the call statistics via the phone itself, via a web page, and we also did a packet capture. We used the Ethereal packet capture utility to capture some of the packets inside of this audio stream, and we noticed the frame size. One of these audio frames had a frame size of 214 bytes. We then changed our configuration so that the next phone call would use G.729. And with G.729, we noticed, again after doing an Ethereal packet capture, that the size of one of these frames was only 74 bytes, as opposed to 214 bytes. We saw that there is a dramatic difference in the size of these audio frames, and therefore a very different bandwidth requirement for these two different types of codecs. And that concludes ONT Lab number 1.